Good morning, everybody. Welcome to the introductory Python programming session. In today's session, we're going to focus on functions and Python, and we're going to leverage a simple tic-tac-toe game to understand how we write functions, what do functions do, and more intricacy details of functions. My name is Vikramaditya Jakkula, and I'm from Data Mining Tools Inc. And today we're going to look at functions in Python. First, so objectives. The main objective of today's session is to enable students and um, beginning learners of Python to understand how to leverage functions and be able to write your own functions to get some activity done or some program delivered. Okay, next, accept functions, accept values. You will learn how to accept values into your functions, how to return values from the functions, work with global variables and constants, and look at the example of a static game like tic-tac-toe to see how you can program it functionally. Next, tic-tac-toe. First, tic-tac-toe. In this screen, you'll see a general representation of a tic-tac-toe. You see the welcome message, then you see different parts of the board. 0, 1, 2, 3, 4, 5, 6, 7, 8, different parts on the tic-tac-toe board. Okay, this. Next. In the next slide, you see the example of a scenario where computer won against the human. So here you see computer is 0 and human is x. O and x, 0 or x, O and x. So we see that it has got diagonal O and it has 1. Next. And this is another scenario where you see the human interactor had actually won against the computer. So here we see the computer's simple programming allows it to be beaten by the user or the interactor. Next, what are functions? Studying functions. So functions, we can define functions on our own, and every function has a particular task to be done. Functions let you to break up code into manageable chunks, right? So if you're looking at printing names, so rather than writing print Java, print Python, print C#, what we can do is we can write a constant function in the top called print and pass Java, C# and Python to it, and it prints it out. So this way you can programmatically do it better. Okay, and there are two things. There are built-in functions and there are functions that is programmatically created. Built-in functions are the functions like string length. So if you import the module of string to the Python program, you can call the built-in function string length to find the length of the string. But you can write your own function called as birthday date. You can have your own function where you can pass a name and date. It's going to print happy birthday for you on that date. This is the example of that. Next, defining a function. So here we see an example of function def. Def is the keyword that is used before every function in Python. Def instructions. So here the function name is instructions, and then the code says def instructions print welcome to the world's greatest game. So here we see that the function instructions when called prints out welcome to the world's greatest game. So function definition, code that defines what a function does. The entire def function, def instructions is called function definition. And the function header is the first line of the functional definition. It starts with def, which is called as the function header. And then whatever task that function does is executed based on the way the function is called. Okay, this. Next, documenting a function. Documenting a function, we use triple strings, this is also called docstring. This is written the next line after declaring the function header and function, and it includes instruction for the coders to understand what the function does. It's not required, but it's a good idea to write what it is, because most of the times there'll be multiple coders working on it. Some people will be appending it, some people will be fixing it, some people will be looking at it. So if you have a well documented code, it is very appreciable. It's one of the good qualities of a developer, a strong developer. Next, calling a programmer created function. So as we have already looked at the function print instructions, where it prints out the standard string or text. Here you can call the you can tell the computer to execute function by calling it. So you define the function, and below you call the function, and then it gets executed. Okay, and next, abstraction, mechanism that lets you think about the big picture without worrying about the details. So you not worry, you can just call the function instructions, and then in Python You can sometimes call it directly and without passing any parameters. Sometimes you can call it with parameters, so it automatically takes it and works as what is passed to it. You understand it more. So using parameters and return values. Just like with built-in functions, normal user-created functions can also accept parameters where you send values to it, and uh, it computes and then it returns the value back to the caller. Okay, so this is a simple example here, sample run of receive. So here you say 5 and it asks you yes and no, and then it asks you to exit the program. It's a simple program. So here we see this. So what is the parameter? In this function, def display message, print message. So in def display, the parenthesis you see message. That is the parameter. And the parameter when the function is called, it says display Python, and then it goes to the function display message. In that it prints Python, and here it takes the message as string. So the argument here, next look at next one. So here we have, give me 5 examples. So it's 5 and it returns the value 5. Okay, so this value returned by a function, return value is the value that is returned by the function to the caller. Okay, from where the function call is happening, you return the value to there. Okay, and we need to note that you have to be careful based on the what is being returned by the function. For instance, if you have a function that takes in string and returns a string, you pass a variable to it, it will give you errors. So you have to know what you're doing with the function. Next, encapsulation. This is a technique to keeping independent code separate by hiding the details. So you write multiple definitions, and based on that the action is done. You understand in the next example that we're going to look at. So look at the example here. Def asks yes or no. So if the response is none, then if the response is not in bias, it asks the user to input a response. So here receive and returning values in the same function. So receive a one value and return another based on what is entered. Receive a value through its parameter. So first one is just direct value, and then the last one returns a value either yes or no through the response sent. So the sample call will be answer is equal to ask yes or no, enter the value, enter 1. So it takes it and it is not yes or no, so it's going to say it's going to give either an error, it's going to say enter y or yes. Okay, next, birthday wishing program. It's a sample run of the program. So here it wishes happy birthday your year. Let's look at positional parameters. Positional parameters are nothing but name and age. In this example, def birthday one, name and age are parameters, but positional parameters and positional arguments. So instead of name, if you pass age, and instead of age, if you pass name, so it might be a bug sometimes, or sometimes it will work. For instance, look at this function here. So here you are passing the value birthday 1, Jackson and 1. So Jackson is the name and age is there. So happily it will print happy birthday Jackson, you are 1. And then if you pass you are 1 and Jackson, it's going to print happy birthday 1, you are Jackson. So computer is not that smart. You have to programmatically instruct it what needs to be done. So that's with us. Next, position parameters and keyword arguments. So here it's exactly the same, but here what we're doing is we are passing the variables by making the calls. For instance, birthday 1, name is equal to Jackson, and then age is equal to 1. We're passing to the function, and then it's going to just print out happy birthday Jackson, you are 1. And then if you pass this way, birthday 1, age is equal to 1 and name is equal to Jackson, it's going to happily print Jackson, you are 1. It's not going to make a mistake, because positional parameters you can understand based on the parameter arguments that you are passing to it. Argument starts with basic parameter. In the parameter name, it will correctly compute it. Next, default parameter value. So this is there. This is in the function definition of your function. You give a default value. Even if you don't pass, it's going to print out the name and age in the default parameter value. So if birthday 2, name Jackson and age 1, just execute the command. It's going to print happy birthday Jackson, you are 1. That's what it's going to print. And if you pass a function like birthday 2 Jackson, name is equal to Catherine, it's going to print happy birthday Catherine, you are 1. So if you just pass birthday 2, age is equal, it's going to print Jackson, your age is 12. It's going to print 12, it's going to print Jackson. Jackson is the default parameter given in the definition of the function. If you pass name and age to it, it's going to give whatever you have entered, but if you pass it without any arguments, it's going to by default print Jackson and 1. It's a default parameter value. And if you print both of them, name and age, it's going to print Catherine, you are 12. This is how it works. You can see them on the screen. So these are the different ways it prints. And yeah, next, scopes. Scope is nothing but a different area of a program that is separated for each other. So every function has its scope. Variables declared in the function are acceptable and work in that duration, in that definition of the function only. It cannot be passed back into the main function or other functions. Functions can't directly access each other's variable. They are secured. For instance, look at this definition function 1. There's a variable 1 in it. Next definition function 2. There's a variable 2 in it, and you have a variable in the calling in the main or the part of the lower function. So this is when you pass the value to it, it computes using the variable and returns the value. So global value and constant. It's a good practice to use global constants and keep your be careful with what you're passing as arguments to the functions. This is another example. So this is another example here. So read global inside the global value is. So it depends on what you are passing. Next, reading a global variable from inside a function. So a variable created in the global scope that can be accessed in any part of the program, and local variable is a variable that is accessible only where the function is defined. You cannot call it in another function outside of the local variable. You can't read the value of a global variable from within from the scope. Okay, next, changing a global variable from inside a function. So when you define your function, you create a global variable value, you assign a value it and print it, but when you call the design the value and call it, it prints a global scope. Okay, so this is another example. Let's see if we have, yeah. Understanding when to use global variables and constant. Use of global variables can lead to global constants are more advisable to use. Global variables lead to a lot of confusion in programming because the next user, next developer who comes and writes the code, he may not be able to understand if you have too many global variables. So he has to look at a lot of functions across different classes, see how those variables are, and then he has to determine how we can add extensions to them. Next, now let's look at the tic-tac-toe game. Okay, so first writing not just tic-tac-toe game, but any application, first you need to figure out the behavior of the game or application. So what are the inputs, what are the outputs? Next, you have to figure out how to represent the data, like what data types you want to use, how you want to store the data, how you want to process it. Pseudocode comes next, but how you want to represent the data, what do you want to do with that, you need to figure that out. Next, you have to write pseudocode. Pseudocode is nothing but a workable piece of code. How does the code work? Write the pseudocode. Then list out all the functions assigned to it. Then code it, and this is a type of functional programming. Next, representing the tic-tac-toe data. So we use a single list of 9 elements to represent the board. List elements will be strings 1 character long. Empty will be quotes. X will be X and 0 will be O or 0. Okay, O it will be O, X, O and blank. Okay, but in Java or C# we can use hash table to load the data instead of just a list. This will make it more faster execution. Next, the tic-tac-toe game board. So this is how the data, the list will store the data. So 0 is one location, 1 is one location, 2 is the second location. So it is then 3, 4, 5, 6, 7, 8. So it's a visual representation of the board game. Okay, this is how you understand. Next, let's look at the pseudocode. So first, display the game instructions, determine who goes first, create an empty tic-tac board, display the board. While nobody is won, it's not a tie. If it's human turn, get the human move, update the board with the move. Otherwise, calculate the computer's move, update the game with the move, display the board, switch turns, congratulate the winner or declare a tie. So this is what different pseudocode for the tic-tac-toe game. Next, functions. The first function is display instruct. Second function is pieces, which stores which returns human and computer X and O positions on the board. Next, a new board. It creates an empty board and returns. Then display the board. You pass the board to it. Winner board returns a piece. It returns either his tie, won or lost. Okay. Then human move. Then computer move. Then your display board which gets updated with the move. End of turn. There's winner identified. Congratulate the winner. Okay. So this is what. And then ask if you want to play one more game, yes or no, and then close it. So these are the different functions of tic-tac-toe. First is display the game instruction. Next is ask the question whether he wants to uh, uh, start or he wants the computer to start. Then uh, then let's look at other functions also, like winner, loser, human move, computer move, next turn, then congratulate the winner. So these are the functions. So summary, it's coming to the end of the presentation. First, what keywords do you use to define the function is def. Next, what is a function header? The line that defines the function. Docstring is a string that is written below the function to uh, help understand what the function does. Abstraction, it's a mechanism to let's to think the big picture without worrying about details. Parameters, a parameter variable or name which are passed to the function. Parameter, argument, or value-based function. Next, return value, the value that is returned from the function. And encapsulation technique, keeping independent code separate by hiding the details. So what is the software use, keyword arguments. So basically in this what you understand is what are the different ways you can write functions, how can you pass arguments, how can you calculate, how do you return the data back, and then how the data is passed to the next part of the code, and then how it is computed there and then passed to a different function. So and you can write multiple functions in the program. It depends on the developer as how many functions you want to write, how you want to do it. But the good practice is write one function to achieve a one task.